All right, this will probably be a pretty short video on shielding effect, pretty easy concept and easy to solve these types of problems. Shielding effect is just this repulsive force that the core electrons have on the valence electrons. So remember that all electrons have a negative charge, and so as we're building up all of our electrons and we have more and more and more and more, you have a bunch of negative charges next to each other. They don't really want to be next to each other, and so the valence electrons will actually feel a repulsion from the core electrons, and what that does is this valence shell will get pushed out. And so that has an effect on all of our trends that we've learned. So if this gets pulled out, right, then our valence shell will kind of extend. That's going to increase the atomic radius. It's going to decrease the ionization energy because now that they're further away, it will be easier for us to remove them. It will also decrease the electronegativity because it's not holding the electrons as close as it would like to its nucleus, okay? But all that really means is that the more core electrons we have in here, the greater we'll feel this shielding effect. The valence electrons will feel the shielding effect. So questions that ask about shielding effect, you really just have to pay attention to how many electrons the atom has. It's that easy. So let's take a look. Here's a question from the notes. Circle the element whose valence electrons would experience the greatest shielding effect. So if we want a big shielding effect, we want more electrons, okay? So we just have to figure out how many electrons each of these things has. Arsenic, antimony, bismuth. Arsenic is here, right? And we assume everything's neutral, so 33 means 33 electrons. Antimony, 51, so we have 51 electrons. Bismuth, in the same family, 83, has 83 electrons. So, looking at this, I know that bismuth has the most electrons, and therefore bismuth will experience the greatest shielding effect because it has so many electrons. All those negative charges next to each other, it's going to push the valence shell out and have an effect on the other trends in this fashion. Okay, so you just need to pay attention to the number of electrons. Pretty easy, so hopefully those will be easy questions for you.